Hi guys, welcome to this new series on feature engineering methods that are traditionally used in most of the AI and machine learning and data science applications. Feature engineering, as you know, plays a very crucial role in improving the model performance, reducing the noise, handling non-linearity, and also, performing some of the pre-processing or analytical type of activities like mission missing data analysis, enhancing the interpretability of AI models. It is, in fact, one of the key aspects of machine learning pipeline. Apart from the knowledge of statistics and mathematics or algorithms, we also need to have significant domain knowledge, data knowledge, and a fair amount of creativity to perform feature engineering. This series is going to be quite comprehensive, end to end. I'll be covering most of the methods that are used in traditional feature engineering. Let's define feature engineering is a process of creating new variables, new input variables, or transforming the existing ones. It is also aimed at sometimes, extracting relevant information from the data, reducing the noise, and performing some of the activities like missing data analysis and finding out the outlier values or outlier data in your, data sets. It also requires significant domain knowledge, as I mentioned earlier, and a fair amount of creativity is required to perform feature engineering. Let's take a look at some of the examples of feature engineering. I'm going to be looking at some standard numerical data as a reference to describe some of the examples here. Sometimes when we have nonlinear data in our data set, we perform or we transform the data set into quadratic or squared or cubed form, and that's called polynomial. That is an example of a feature engineering. Sometimes we have data which is skewed in nature, which is basically non-normal sort of data, and then we apply log transformation as one of the methods to convert into a Gaussian distribution. So that's another example of feature engineering. Let's take a look at some of the feature engineering examples for the text data. As you know, the text data cannot be processed by computers directly, so we need a mechanism to convert the text data into numeric, and some of the methods are mentioned here, like TF-IDF vectorization and word embedding. These are nothing but algorithms which convert your text data into a number format. So these are also examples of your feature engineering. Similarly, for image data, we might want to do feature engineering in terms of understanding the distribution of color pixels in the images, color histogram, and also finding out the edges in the pictures. So those are examples of your feature engineering for images. Why should we actually perform feature engineering? Let's look at some of the examples here. The goal of feature engineering is to improve the model performance by focusing on really the relevant columns or relevant features by understanding the relationship within the feature. That's the overall goal of feature engineering. Other goals, noise reduction, minimize the noise from in the data. And why so? Because noises in the model or in your data cause the model to overfit. So in order to contain the overfitting pattern, we need to reduce the noise in the data set. Sometimes our data can be very nonlinear, and we need to convert it into a Gaussian or a linear pattern. We apply feature engineering. Some more reasons, handling missing data. If in the column some of the values are missing, then we perform feature engineering. It's essentially strategies. Missing data is not a trivial job. So we need to figure out, what strategy really makes a meaningful sense to, fill up those missing values. Another goal of feature engineering is to provide interpretability of the data and hence the model. Overall, it allows us to have a optimized model or more generalized model, and which is basically one of the features of well-optimized model is the model which really converges well. So, what are the categories within the feature engineering? What are the main types of feature engineering? Feature selection is one, and some of the methods that we will be going through in the subsequent videos. Feature selection deals with methods which are specific to column, understand the column or pair of columns or group of columns and perform some analysis. And after the analysis, so we may want to drop some of these columns. The methods that are used are filter methods, wrapper methods, and embedding methods. These are popular methods under feature selection. We'll be going through each of the three in significant detail. Other category is called feature extraction methods. Here, we are not looking at specific column or feature. Instead, we look at the whole data set and try to find out alternate representation of a data set which allows for faster processing or faster model building and better performance. These two methods are popularly uh, used under feature engineering. We will also go through all the exhaustive list of methods that are used in the feature extraction, like PCA and t-SNE and some of the other polynomial transformations. So some examples of feature selection methods like filtering methods, which is basically, you look at a couple of columns and pair of columns or more than two columns and decide which columns to keep and not. For example, if you're predicting the student success, you would like to keep the variables which make more sense to predict the student success and exclude the less relevant columns. Eliminating redundancy is another useful technique used in the feature selection method. For example, if you have two columns and they are collinear, and that means the one column can be expressed as an equation of another column, then we can only keep one of them. So that's one of the technique that we use in. We'll see how to detect those redundancies in the data set in the subsequent videos. And keeping the essential means you keep the um, bare minimum or the columns which are really useful in predicting the outcome. Some more examples of feature selection. Simplifying complexity. So when you have lots of column, and then the model tends to actually overfit, and it doesn't really generalize well. So you might want to think of how we can, reduce the complexity of the model. Avoiding overfitting. This is a very big problem in any of the machine learning or deep learning. So with a lot of columns and also the model parameters getting complex, it tends to memorize, and that's the pattern called overfitting, and that means it will do well with your training data, but with the testing data, it will not do well. Let's see one more example here. Feature selection. Keep the features which are useful and bare minimum to predict the outcome in a way to enhance or provide a better interpretability. Extraction methods, as I mentioned earlier, these are methods which do not deal with specific individual columns. Rather, here we are looking at a complete data set and finding the alternate representation. Sometimes we also transform the columns in order to get a better representation of the data. For example, if you have temperatures in the Fahrenheit and Celsius and combining, let's say, height and weight to create BMI. So we can use either height and weight, or we can use BMI to represent the feature. So feature extraction does not necessarily mean the reducing the number of columns. It is more in terms of finding the alternate representation of your data set by using some of the advanced mathematics like PCA, eigen decomposition, singular value decomposition, factor analysis. All of these methods we will cover in this video series. Dimensionality reduction is one of the very popular feature extraction methods. Here we are talking about, let's say we have 1,000 columns, and is there a way to reduce the number of columns from 1,000 to, let's say, 10 or 20 or 30, and still not lose the data or information in your data set? And that's called dimensionality reduction. And some of the methods which are popularly used in dimensionality reduction are PCA, for example, principal component analysis. There are many other methods: singular value decomposition, factor analysis, non-matrix factorization. All of them are very popular methods under dimensionality reduction. Feature selection methods, back to feature selection, some of the examples that we will actually go through: correlation analysis. So when we do correlation analysis, the objective of correlation analysis is to find out, do we have extremely high correlation within the predictive variables, or do we have low correlation within the predictive variables, and between the predictive variable and the target variable. So that's correlation analysis. We will look at each of the scenarios and figure out which ones are the one that we should address given a scenario. Information gain is again a popular feature selection method, as you have seen in decision trees and the random forest or ensemble methods, where we have each of the column associated with Gini or Gini index, or any other mechanism that you might use, for example entropy, and we can use that to sort the column in terms of information gain. So the column at the top would be more discriminatory in nature, more useful uh, to keep. Mutual information is another feature selection technique. Variance threshold is another technique where we look at the column and the variance is present in the column, and we will see why low variance is not useful in machine learning. Some more methods that we will go through are feature selection methods: ANOVA, chi-square, and t-test. These are hypothesis testing methods, and they're also used quite significantly in feature engineering space. But feature engineering is quite challenging. Um, you need proficiency in domain data and also fair amount of creativity. It takes time. It is quite iterative, and you have to make sure all the possible methods that we have used, which can use, are actually used in feature engineering before we make a decision of removing column, combining column, transforming column, or finding alternate representation for our data set. Let's take a look at the taxonomy of the feature engineering methods that we will actually go through. Let me highlight some of these here. I'm going to be first focusing on the filter methods: variance threshold, correlation analysis, information value, univariate feature selection. All of them are listed here. We will go through ANOVA, chi-square, t-test, and also some of the non-parametric methods. Wrapper method, this is a machine learning based method: forward selection, backward selection, and RFE method, quite popularly used for feature selection. Another feature selection technique that we use is embedded, which is, in other words, is a shrinkage method, popularly known as regularization as well. Lasso, ridge, elastic net. We'll cover these under embedded method. And then we move to more comprehensive and challenging part of feature engineering would be your feature extraction methods like dimensionality reduction, PCA, LDA, singular value decomposition. And then lastly, we'll cover factor analysis. Okay, so the next we will cover the filter methods in detail. Thank you, and we'll see you in the next video.